I'm trying to find this z-score, and then I'll find the value. Then I'll find x. I gotta get the z-score first. I gotta find how many standard deviations above the mean. So let's look at our table, page 5 now. 0.95 is 1.65. So this z-score is 1.65. By the way, notice how they're very similar. Hey folks, notice the similarity here. That makes sense because 5% of the data is less and 5% of the data is more. Mm-hmm. These are corresponding z-scores. One is on the positive side, one on the negative side. Anyhow, then we set this equal to x minus mu over this. What do we get?
7.952.
7.97?
I got 7.952. 97?
Yeah.
How?
Because you multiply and then you add 5.
Questions?
Why wouldn't it be the same?
Probably.
1.04.
1.65.
I mean, it's basically the same. There's some like rounding that has gone on here to like make this a table. And see, this one is negative because I'm going left. So it's lower than the mean. This has to be a positive number because it's standard deviations above the mean.
But I would still be finding the answer here.
No, on page 5.
Oh, okay.
Because you want 0.95 now. This is 95% of the data is less.
But I don't see
0.95?
No, I don't see the 0.05.
No, because you already had the 0.05. But here, at this point, Kendra, how much data is lower than here? 95% of the data is below this.
Oh, it's 0.9.
So it's 0.95.
It's on the positive
Questions?
side.
So why would I?
So this is for
So
the,
why?
this is for
Okay,
the,
why?
this is for this. You see how like this? This is for this
Alright.
part. And that's
So let's do the AP problem from 1997. This is the hardest AP problem ever on this topic in all the years. The AP exam has only existed from 97 until this year. This is the hardest one they've ever asked. We have copies of every
So
question.
the question is asking us to look at the bottom 5%.
No, I said skip that. Skip that.
So for the bottom, you look for 5%. You want to put this over there?
Yeah. Is that good? All right. So here we go. The distribution of weights, and we need everybody here with this. This is hard. This is hard stuff, folks. This is hard stuff. All right, folks. Here we go. The distribution of weights of loaves of bread from a bakery follows a normal distribution. Normal distribution. This is the 1997 problem. So I'm going to start with the picture. It was found that 10% of the loaves weighed less than 15.34. So let me draw this. So right here, this is 15.34, and I know that in here, how much area is here? 10%, so this is 0.1. 0.1. Again, let's take it very slow steps. We'll be able to get this, folks. Let's just take slow steps. The next one says 20% of the loaves weighed more than 16.31. So here's a 16.31. And 20% of the loaves are here. Shamar, we'll start here. Hold on. Is it, no, I thought it said that 20% are bigger than that. So more than, right? No, hold on, yes. So we'll get to what it means. So it means that 20% of the loaves are bigger than this. 10% of the loaves are less than this. Right? So 70% of the loaves are in here. Okay. So let's see what we can do. Let's see what we can do. I know that if I want to find the z-score for this, If I want to find the z-score for this point, okay, by the way, somewhere in here is the mean. Who knows? We have to, that's part of the work is going to be find the mean. But we have to find, let's get this z-score first. Take it slow. Think to yourself. Think about this. What do you want to look for in the table? For this point, forget about this one. Just focus on this point. Think to yourself, what do you want to look for in the table? And then go look for it. Think about what the z-score should be for this point. Just slowly think to yourself. Use the logic. Think about how much data is behind this point. That was a nice... So, and just think, no need to shout out. The value you get should be, don't shout it please. This is what I got. I was looking for 0.1. That's what I was looking for on my z-score table, and I got this. This is what I got. If you didn't get this, you got to try it again or ask a question. Try again first. Understand why we're looking for 0.1. Those who are good, try to find the z-score here. Try to find the z-score here. Questions? Any questions on the first z-score point? Dexter?
Is that the z-score?
Yeah, this is z-score right here.
Did you already find that one?
No, I haven't found it. I'm about to. Shamara, is this making sense? Okay, I'll give you a second. Okay, so I'm going to do this one. And think about it. For this z-score, think about how much area is behind it. Always want to think how much is over here behind it. So I would look for this. I'm not going to say it. I would look for this. If you're still thinking, don't look up here. That's what I would look for. And then I would go look. Give me 1 second. Give me one. This is what I'm getting.
Why are you looking for 9 plus 2 is so less? So why would you be looking for more?
Oh boy. Oh boy. Ay, ay, ay. Ay, ay, ay. No bueno. Excuse me, folks. Thank you for keeping me on my game. This is a z-score I got. Okay, so let's take the questions on the z-scores before I go further.
Can you show me how you got it for the first part?
This one?
Yes.
So, are you good that this has to be 0.1? This pink? So on your table, you looked and found 0.1 on page 4? Shamara?
Oh,
0.1. Shamara? Next. Why what? Because it says 10% of the loaves are smaller. So 10% is 0.1. BJ, if you're convert decimal.
Why are you looking for 0.8?
Because how much data is behind this? If a 0.2 is above it,
Oh, okay.
0.8 will be behind it.
Yeah.
So you tell me, oh.
So you're not gonna look just for the 0.2?
No. Always look for how much is behind.
I did do the math, but 10% is
Now.
That's more than 1.1.
Yeah, that's right. That's exactly what I'm saying. Now, here we go. We're almost finished, folks. Almost finished. So now this negative 1.28 equals what? It equals x minus mu over standard deviation. Shemaya? Right, yeah. I'm going to plug that in a second. Absolutely. And over here, same thing. X minus mu over standard deviation. So, as Shamira said, and I'm sure others have seen this as well, let's plug in the x's we know. They already gave us those. So over here, I've got negative 1.28 equals 15.34 minus mu over 1.8. And over here, I've got 0.85 equals 16.31 minus mu over standard deviation.
Where did 1.8 come from?
Isn't that the standard deviation? What is this?
We have 9 guys that deviation.
What point 2.8?
I'm proving my immense amount of humanity here with all these errors. Okay, so now we have 2 equations, 2 variables. Back to Mr. Curve. Multiply both sides by standard deviation. Let me start bringing. There's gonna be a lot of math here, but there's no more stats. The stats is over. Now it's just algebra 2.
Why? Why?
1, 2. That's much slower. And what if it's free response?
Much slower.
So here we go. I'm going to cross multiply, folks. You got to stay with me here. All right. We got that much. Just cross multiply it. So now I'm going to add this over here, because I want to isolate this so I can plug it into the other equation. The way to solve 2 equations is isolate a variable and plug it into the other equation. Substitution, as you may have called it with Mr. Curve. So let me add mu on both sides. So I've got mu minus 1.28 equals 1.28 standard deviation. Give me 2 minutes, folks. Follow along on the board. Just give me 2 minutes. You'll see it. Add 1.28 theta. Theta, standard deviation. Sigma. This is a sigma. Sorry. So I've got mu equals 15.34 plus 1.28 sigma. Take this and put it here. For the mu in the other one, so that you now have just one equation over here with one variable, sigma. So let me solve this equation. So I've got 0.85 sigma equals 16.31 minus, here we go, 15.34. Not going to have enough space here.
Remember, the camera can't catch you right there.
Really?
Well, too bad. So,
1.28 sigma. Please note this needs to be in parentheses here. Distribute the negative. So I've got 0.85 sigma.
Why wouldn't you combine right there?
Well, but this is inside, this is with the negative out here. So we got to first distribute the negative, then we can. And remember, this negative is going to make this a negative here, or a minus. So minus 1.28 sigma.
skillet. It's a skillet. It is. It's like a skillet.
Now, combine like terms here. 16.31 minus 15.34 is 0.97. So I've got 0.85 sigma equals 0.97 minus 1.28 sigma. Now, add 1.28 sigma here. So we've got 0.85 sigma plus 1.28 sigma equals 0.97. 1.28 sigma. Victoria?
I'm confused about the 0.97. So when I gave over the negative, but I put plus and then I brought out an extra negative to get to opposite. So why isn't it?
So this is a positive number.
Yeah,
This is positive right now.
it's gonna be negative.
It becomes negative, so I've got a positive minus a...
But you're supposed to be a plus there.
No, because I distribute the negative here.
That's what I'm saying. So if you distribute the negative, right, it'll have a negative regardless there. So
If I have
you're
this,
already subtracting.
If I have this, doesn't this become this?
Yo, but when you keep adding that,
So I have a 3 out here, so it's 3 minus x minus 5. I'm not going to be adding it. Or you can say, if you want to say it differently, 3 plus negative, same thing. You could have put a plus sign here if you do plus a negative number.
Yeah, that's what I said, plus or negative.
Right, so 16.31 plus negative 15.34 on your calculator will be positive 0.97. Now, we're almost done. 2.13 sigma equals 0.97. Divide by 2.13. Divide by 2.13. Sigma equals 0.455. And now, make your life easy. Don't plug it back into one of these equations. Take it back right here. Life will be easier. Take it back here. Okay, so assume it's free response, guys. I can make it really hard to make free response. So plug this back in here to find mu. So 0.455 goes right here. So we get what? 0.85 equals 16.31 minus mu over 0.455. And this problem is really solvable. Cross multiply, solve for mu. And you have to, and I hope you're going to get a number that's one of the choices. And in fact, you do. Mu is 15.93. Too much?
Too much?
And that is answer choice D.
It's an overload.
And that's one problem on the statistics exam. So, here's where we're going. Hold on one second. Guys, too much noise. Too much noise. So hold on. Couple things. One is, tomorrow, the first thing I'm going to do is do this next problem about the Virginia's cooperative. That's much easier than this. It's a different skill, but it's much easier. That will take us about 10 minutes. You'll then have the rest of the period to do your choice of homework, problem sets, or project. Your choice. You all decide. Okay, Monday I will teach something for half the period, and then you will have some more project/homework time. Tuesday we're presenting. Every group must, guys, too much talking. Every group must have a PowerPoint for Tuesday. How many people think it would be helpful tomorrow to have a laptop while they're working? Are there any groups for which that would be helpful? Okay. Is that something are students allowed to bring those? I don't know what the rules are. Seniors are? Okay. Okay, so if you need a laptop tomorrow, guys, if you need a laptop tomorrow, please go ahead and bring that to work on. You're going to need to have Excel and PowerPoint.
Does a nuke count?
Hold on. Tomorrow, what is due? The journal entry you picked up yesterday that says due Friday. What is due on Monday? The problem set you got on Tuesday. And this is due, what day is this due?
Tuesday.
This is due on Tuesday. So one thing a day. So now let me take questions to Kurtja.
Oh, I just have a suggestion.
Okay.
Everybody should use Google Docs because you can include your whole group in it or whatever.
Okay. Yeah, you can use Google Docs for sure. Okay. Now, I'm scared to ask this question. How many groups have not done their survey?
Well, I might as well say me.
At least keeps on going MIA.
I have pounds.
Okay.
I have pounds.
Guys, the head of Yes Prep is coming. We gotta be good, guys. We've gotta be good.
Oh, be bad.
We've gotta be good, guys.
Be bad and get the pity.
Norma? Oh, good. Oh, great question from Norma. Okay, I did really good. Hey, 4 minutes left. Let me talk about what's in the presentation. Great question. Thank you, Norma. So, guys. Why is there so much talking all the time? We're literally recording the ground.